Hello all, welcome to another video of mine. This is nothing but the continuation of Industrial Internet of Things. So in the previous video, we have learned about the definition of sensors, definition of transducers, and the different types of sensors which we had. So here we learn about the sensor characteristics. The two characteristics are the static characteristics and the dynamic characteristics. So after steady state condition, static characteristics is nothing but after steady state condition, how the output of a sensor change in response to the input signal. That is nothing but the static characteristics. So dynamic characteristic means properties of the system's transient response to an input. When the system can change dynamically immediately, then we say it as dynamic characteristics. When system cannot change the behavior, then it is called as a static characteristics. So these are the two types of sensors which we have, sensor characteristics which we have with the sensor elements. So other than the sensor characteristics, static and dynamic, we have accuracy and range also. Accuracy represents the correctness of the output compared to a superior system. The difference between it is totally different from the standard value and the measured value. Range means it usually gives the highest and the lowest value of the physical quantity within which the sensor can actually sense the value. Range can also be told as beyond this value, beyond this particular range, there is no sensing or no kind of response. So that is the particular limit after which the system cannot work. That is the meaning. Another characteristic is nothing but the resolution and the errors. Resolution provides the smallest change in the input that a sensor is capable of sensing. Resolution is the highest specification towards selection of sensors. It is usually higher than the resolution and better than the precision. So resolution uh, is so very important. When the resolution is high, then the precision or the accuracy will be very good for the system. That is the main meaning. The errors are nothing but the difference between the standard value and the value produced by the sensor. Say for example, if the standard value is 2 and if the sensor is giving a value of 2.3, then the difference between 2.3 and 2 is nothing but the error. 0.3 is nothing but the error. So next one is sensitivity. Sensitivity indicates the ratio of incremental. It is like a formula. It is the ratio of incremental change in the response of the system with respect to the incremental change in the input parameter. It can be found from the slope of the output characteristic curve of a sensor. Linearity. Next one is linearity. The deviation of sensor value curve from a particular straight line. So if it is linear, if something is very straight, then we say it as linear. Then the property of moving from the input signal to the output signal producing a constant value is nothing but linearity. Drift. The difference in the measurements of sensor from a specific reading when kept at one value for a long period of time. So, say for example, if we are there is a change in the output signal, but for a particular input value for different time period. When the time period is changing, what is the change in the output signal? That is nothing but drift. Repeatability, the deviation between measurements in a sequence and the same conditions. So same conditions will be there, but the change in the output signal is nothing but the repeatability. So now we are getting into the dynamic characteristics. Zero order system. The output usually shows a response to the input signal with no delay. Without any delay, when you produce a input, if you get an output immediately, then we just say it as zero order system. It does not include energy storing elements. And example is nothing but potentiometer, which measures the linear and rotary displacements. So the next order system is first order system. When the output approaches its final value gradually, we say it as first order system. When the first order system consists of energy storage and a dissipation element, then we say it as first order system. Second order system means it is nothing but the complex output response. The output response of sensor oscillates before the steady state. Then we say it as second order system. I hope you would have learned from this video. See you in the next video. Until then, it's a bye from Radhika.